Well, happy Sunday. Welcome to you, Holly Pascal. We're so excited that you're joining us today. And for our listening audience, tell us a little bit about who you are and how you came to be involved in space.
Hey, thanks for having me. So I was doing my undergraduate in computer engineering at Florida Atlantic University, and I saw this pamphlet for a cube satellite at FAU for a club called Aerospace Experimental Association, AXA. Brand new club, brand new thing. And I went to a meeting and I met Jake Pearman, who some of you listeners may know. And we were in this room together, and I was just blown away by his leadership capabilities. And as you know, some clubs, when you're running things as an undergraduate and you don't have too much input from professionals or the industry or the college, projects can get kind of frustrating or they don't really get complete, things like that. And so I walked into that room and I saw Jake Pearman, and I was in for this project. It wasn't at first so much about the satellite. That was just a bonus that we got to, work on some cool space project. And by the end of that project, I would have followed Jake to the end of the earth. I still would. And so he's the one who really got me interested in satellites, something I didn't even know that was on my radar. And so I led the team on the ADCS, the Attitude Determination and Control Systems, for that. And that sparked a passion inside me. I was sitting there for like, I don't know, 12-hour sprints just researching, ADCS, just going through papers and journals and all sorts of things. And so that was my passion. And then I got a job for L3 Harris, the space industry. I was working on public safety radios, and then I got into their engineering leadership development program, and I got the opportunity to see what other opportunities within the company I wanted to pursue. And I said, I want to do weather satellites. I want to work on weather satellites. I have a kind of personal mission where I want to definitely help people live my life towards creating a positive impact in the world. And I want to do that through technology. I want to do it through the space sector. And so now I'm currently working on the payload for the next generation weather satellites.
Wow, that's a lot. I want to back up for a second, though. You'd mentioned, so for our listeners, you'd mentioned you were involved in the attitude, was it the
ADAX.
development? So ADAC. So let us know a little bit more about what that is. Is it directional? Like, I mean, for laymen like me, I'm not going to really sure about the attitude kind of portion of it. So that part, and then is that something that ultimately is done with the balloons as well, or the weather satellites rather?
Yeah, so the ADCS, you can pronounce it however you want, ADAX. It's all about where the satellite is and its orientation. So it's how do we tell in the vast galaxy where our satellite is, if you're in an orbit where GPS may not work. And as you get more of an accuracy of figuring out where your satellite is, things get exponentially more expensive. And so the ADCS is typically one of the most expensive components of the entire satellite. So I remember when I was at the SmallSat conference just this last weekend with Kevin and the Wolfpack team and everyone, we were doing the PDR, and yeah, the ADCS portion was, I don't even triple the amount of any other equipment there. And so it's a very, very cool thing. And so one of the most expensive types of attitude determination and control, figuring out where you're at, is using a star tracker. And so it's a little camera that has typically a predefined catalog of all the stars, and it takes an image of the stars and analyzes it, and then it can roughly tell it its estimation based off that. And so that's the coolest way to figure out where you are, the most expensive as well. But it just depends what kind of mission you have. So if you're on a mission where accuracy doesn't really matter of where you're pointing at the Earth, that can oftentimes leave you with a less expensive path. And if you need a super high degree of accuracy, maybe you're working with reaction wheels, a lot of reaction wheels. And so it all depends around the mission, how much accuracy you need to detect where you're at and where you're looking at on the Earth.
Right. And to add some color to that great description. If you need to point your camera to the Earth, number one, you need to know what direction are you currently pointing, and then two, you need to have the ability to change the orientation of your camera, or it doesn't do much good. We can't image the hurricane if the camera's pointing out towards the moon.
So is that something that can be done with the weather satellites that you're working on as well? Like, do you need to be able to do that same kind of thing in order to get the information back?
Yeah, so it's really interesting with the weather satellites. So it's a contract with NASA, and it's the GOES R series. Well, currently in 2032, we're going to launch the new generation of weather satellites, which is not the GOES series, but the GOES series has been around since 1985. It's still the same one that we use in space today. If you're looking at your phone checking weather, chances are the weather data did come from the satellite called the GOES series. And it's geostationary, and so in order to it's above the equator and it follows the Earth just around with us. And so if we were to look at it, it appears that it's stationary, even though it's really not, but to us it looks like it is. And in order for it to move, besides this little camera mirrors that it has on it, it's able to rotate. But if it wants to get a bigger view of frame, if it wants to move a little bit, instead of actually shifting left or right, what it does is that it slows down or it speeds up. So if it moves closer to the Earth, that means that the Earth has less time to move, and so it views like it's shifting. Or if it needs to go view the other way, then it goes out of orbit a little bit, moves out, and then lets the Earth rotate at a faster pace. And so this is just something that I recently learned in order to present at the Kennedy Space Center last weekend. And so that kind of blew my mind. So I wanted to share that with y'all if
Sure.
there's anybody else behind the scenes geeking out at that fact.
Yeah, in fact, the almost hard thing to grasp is you speed up to slow down in orbit, and you slow down to speed up in orbit. So that's fascinating. So the GOES, what is that? Probably something like geostationary Earth observation satellites, something like that for the GOES
Yeah,
acronym.
yeah.
So they have a box, right? A three-dimensional box that they'll live in for their lifetime over some line of longitude. And they have some discretion to tweak their orbit, but they have their own little, there's probably one over North America, right? And how many GOES satellites are operational now? That might be a good question.
That is a good question. I don't quite know. Typically, there's two that are operational, and then one or two that are acting as an on orbit storage in
Right,
case
right.
something goes wrong. Yeah, on GOES 17. So in 2019, there was a problem with the loop heat pipes where debris got caught in them. And so it wasn't able to take the pictures as accurately as it needed to. And so luckily, GOES 15 was floating around, just hanging out in case something did happen. And so for a couple years, they would power it back on and take images of the Earth twice a year to help compensate for that data loss.
Right. So the heat, you mentioned the heat pipes, the thermal management. Sometimes heat builds up in satellites, and it's very difficult to move heat in a vacuum, right? So we use, what is it? Probably ammonia or some kind of liquid that gets volatilized inside a tube. It goes outside in some exterior region of the satellite, and then we radiate that heat into space. So I always thought thermal management was very fascinating, but we tend not to have to worry about that with our little small CubeSats in low Earth orbit. The Earth is a nice buffer for temperature extremes in orbit.
Right, and that is great, and that is a huge money saver as well, because I know that on the ABI, that's the instrument that currently takes the images for the GOES series, that the actual instrument needs to be cooled, certain aspects of it cooled or heated to these extreme temperatures. This is a terrible guesstimation. I forget what the actual number is, but it's something like it needs to be the actual lens needs to be negative 350 degrees or something just unbelievable like that. And so you're thinking that, in space must be pretty cold. And so it needs to be either colder or hotter, different parts of it. And so, yeah, definitely if you have a clog in the system, that can lead to some crazy stuff. But it is much nicer seeing how with cube satellites in low Earth orbit, there's things that you need to worry more about, like tumbling, and then there's things you have to worry less about, like the heat.
Well, I'm going to take this back a little bit to FAU because I know you mentioned Jake, and of course, I went to FAU. When I went to FAU, there was not
Oh.
a very solid aerospace, and not that I would have gone into it, of course, but I mean, it wasn't known for that. And yet, more and more, after talking with Jake and a few others, and some of our students who are now going to FAU, we recognize that it's actually an emergent kind of engineering and aerospace school. Do you want to talk a little bit more about the program there and your involvement and some of the programs that might be coming in the future?
Yeah, I'm so excited that they are trying to launch a aerospace undergraduate and graduate degree there. There is currently an aerospace certification at FAU, and it went very well. They had a lot of interest in it, and so that's helping drive the force for these degrees. I heard about it a couple years ago when we were starting AXA, and it wasn't quite a thing yet. And I am so glad that they are that there's still interest, and that that is something that actually might happen. And so
Well,
if there's
remind our listeners what AXA is. I know that was like Jake when he talked about it, but it's been a while.
yes, Aerospace Experimental Association. So it's a club at FAU. We started I was one of the founding members a few years ago. So that's when we were designing the FAU's first cube satellite, and we had no idea what we were doing. We were just a bunch of undergraduate kids trying to figure it out, and it was so much fun. And so I think between that, and then there's another club called TAC at FAU, and that does similar things. I think they're more a rocket and propulsion oriented. But yeah, between those two clubs, there is a growing interest, and so any industry professionals who may be listening to the podcast, if we would love your insight, that we have a survey to fill out to try to get traction for the aerospace degree. Just it's like a 2-minute survey, seeing what companies are hiring aerospace engineering and trying to build a case for a need for it at FAU.
Well, if you send that to me, I'll put it in the show notes, and so that people who are listening can kind of click on that.
That would be awesome.
Right, and I've spoken many times with Dr. Curette, and did you know a Dr. Araki Asami? Everybody calls him Rocky.
I believe so. Yeah, his name sounds familiar.
Yeah, he's a computer engineer, or computer engineering, computer science. So between the two departments, right, the mechanical, where you and Jake probably work more with AXA, and the computer science, computer engineering folks, there's definitely a thrust now and interest to get this aerospace off the ground. So one of my goals this year is to get some funding. We're going to attempt, the Wolfpack kids are going to advocate to get some funding for to help support building the first FAU CubeSat. So it probably won't be enough money for a 6U, but it'll definitely be able, you'll be able to build something, the FAU kids will, and get it launched. And that adds a lot of credibility to your desire to build an aerospace program if you have a spacecraft on orbit. So
absolutely, and I can't think of anybody better to help us along that journey than you, Kevin, with your proven track record of launching these CubeSats.
Well, what's funny is some of our kids at FAU high school are already wanting and a part of AXA, which is a great opportunity. So what we want is to have opportunities for our students, but AXA is now providing opportunities for our kids that may one day be at FAU proper. They're in the FAU high school now. So I'm really glad to partner with AXA, to do some good for the school.
Well, and I want to talk to you a little bit about the role of women in this career field. And I know that that's an area of importance to you. And certainly when we look at our group, we see a lot of boys. We have these few girls in there every now and then. But tell us a little bit. I know you mentioned your goal is to kind of like shape the world and make an impact in this way. And you're being recognized as, I believe, in an upcoming magazine edition as well. So tell us a little bit about how it is from your perspective, having to fight with, the kind of stereotype and what we need to do differently as educators, sending them your way.
Wow, thanks for asking that. That's a loaded question. Let's see. But yeah, it is stereotypically a male-dominated industry. And so I remember going to school. I was definitely one of the only women in my courses, as many of the women probably still are. And what we can do is, if you have a job in STEM, who are also going for a STEM career, like help them get jobs in the industry, bring them to where you work. But honestly, I struggled with that for a while. I was like, I didn't feel like I was really doing anything but just being here in STEM, just being you, going for it, following your passion, is you are a role model for other women in STEM. And especially with, I was talking at the conference with the person, Lisa, who runs the MIT Beaver school, working with young kids in STEM, and they are super focused on, they even have a female only young STEM program, which is absolutely fantastic.
Right. That's Lisa Kelly at Beaverworks. Right?
Yeah.
Lisa Kelly.
That's important to note, that having that separate space where girls feel safer to be heard, to see more people who look like themselves. I mean, that's one of the idea of STEM identity. You know, oftentimes we've talked about this before, like identity in general, about what students think they're good at happens really early. So even in underrepresented populations where they're not seeing people who look like them in those career options, they won't even know what those career options are if they're not exposed to them very early on. So I love that they're thinking about, how do I make a safer space for women to feel comfortable in this environment?
Definitely.
All right. I want to mention, and we talked about this past weekend when we were together at Kennedy, is you have a blog that I've read, and I read I think it's monthly, perhaps, maybe about monthly. And, but I've definitely read your blog. Why don't you share with our audience a little bit about your blog?
Oh, thanks, Kevin. Yeah, so it's called Skyrocket to Success. It is supposed to be bi-weekly. I do get out typically, hopefully more than once a month. Sometimes I do slack though. And so it's on leadership development and helping young professionals launch their career, leverage their education to achieve their dreams in the professional world. So in my college years, there was a lot of, I don't know how to explain it. Even the best coders, I was computer engineering, and so even the best, they would sit there and say, "Oh man, I hope I can get an okay job when I graduate. I don't know." And it was this kind of mindset that was very desperate almost, not to be extreme. And so one day I stepped back and I said, wait. Why do we have such low standards for jobs when we graduate? These jobs are out here working on payloads for satellites or whatever is within the young people's definition of awesome. It's out there. Our dreams are literally here. They are waiting for us. And so I help teach the strategies and the tactics for college students to help get awesome jobs after they graduate.
Good. Yeah, I was just thinking that when we open it up for ideas for workshops next year at our conference, you should put in to do a girls workshop on either working in aerospace or leadership, or any way you wanted to organize it. But you should let's just agree online that that you'll lead a workshop next year for the girls.
I'm going to write a note of it right now. I love that idea.
Well, and I'm also thinking, on our website for the Aerospace and Innovation Academy, we have a blog that usually is based off of kind of like our podcast. But I'm thinking, if you're interested in getting a little bit more exposure, not that we're like any kind of influencer or anything like that, but maybe we could mutually host your newsletter / on our blog on our website as well, if that's something you're interested in. But
I'm always down for collaboration. That would be great.
All right, that sounds good, because we're always looking. The girl who does our blogs is actually a high school senior, and she's about to graduate, and it's just like been so much on her plate. So anyway, check it out. aerospacehigh.org is the website, and you can see our blogs on there.
So what is the future? What do you hope is your future, the next few years in industry, or What are your plans that you'd like to share with the free world?
Oh boy. So I definitely see a future for myself in space and satellites, and I hope to learn as much as I possibly can about everything, which is a very loaded task. It is going very well. I'm very fortunate to have some mentors that are teaching me a lot. So I'm drinking less and less from the fire hose by the day, but I'm definitely hoping to start giving back more. And so I would love to have some mentees of my own. I would love to host those workshops that you mentioned. And I would, I just, I want to get more involved in any way that I can.
That's
I think
great.
she would be great to talk to the Wolfpack, but also I'm thinking about the girls who are working on the no, what is the book,
Graphic
the graphic
novel.
novel. They could use a mentor.
Yeah, we're trying to. I'm trying to get a comic or a graphic novel about characters, and the real secret is we're going to trick kids into learning about advanced space propulsion through the guise of a comic book, a well done comic book. And I'm an ambassador for something called Limitless Space Institute, and they're beginning with the Casimir effect and directed energy, but a billionaire has started this nonprofit with the goal of eventually getting to the Alcubierre drive, which is warp drive. You fold up space in front of your vehicle, you stretch it behind the vehicle, you can violate the speed of light without violating general relativity. So I wanted to
He's got
make
these
a
little
comic
middle school
book.
kids working on this
Yeah.
concept, right? So
Yeah.
they've taken it far enough to where they have twins who like go
Yeah,
out into
we have
space and they get these
characters.
issues, but like
Right.
they're at a loss for
It's
having a mentor who knows the
yeah, none of us know how to
science.
be, we're not graphic novel
Well,
people.
not just that, like they
but,
don't have somebody who can kind of.
But we really do need
guide
a leader there to help organize. There's I think three or four teenage girls and one young man that are sort of active in it. And they all have ideas and enthusiasm, but I don't know how to channel it. It's much easier to do, like a small unit tactics military type thing or build a CubeSat than to make a comic book.
Well,
So that's outside my
it's
wheelhouse.
not really a
Who are
comic
you?
book. That's
Yeah.
the thing. It's not a comic book. It's got to have a lot of.
It's
of
definitely
text.
it's definitely and I had seen one years ago put out by the Welding Society, and it was an Iron Man comic book, like old style comic, but the whole the thrust of the book was pointing kids towards careers in welding. And I thought, what a neat way to grab the attention of young people in
Yeah.
a medium that they enjoy. So that's where we are on that. But anyway, one last question for you. I think you work in the Northern Virginia or DC area. Is that correct?
I was, and then 3 months ago, I just moved to Fort Wayne, Indiana.
Are you kidding? Do you know where Upland, Indiana is?
Oh no, I think she's frozen. Oh, she's back.
Oh, excuse me.
Oh,
Do you know where
there we
Upland
go.
is?
Okay.
Upland is halfway between
No.
Fort Wayne and Indianapolis. It's on Interstate 69. It's in the middle of the cornfields. The exit you would recognize as Gas City.
Is it close to Chesterfield?
I don't know, but
Oh, I think we're back. Okay.
Yeah, the reason I say that is the company that I partnered with in 2016 till now is headquartered in Upland, Indiana. It's called Near Space Launch. And when I met them, they only had 18 radios in space, and now they have 800 systems and over 100 satellites. So I lean on them for like high altitude balloon hardware. We love their radios. They always turn on in space. And I buy a lot of CubeSat components from them. And I send middle school kids with or without me to Indiana to work with their engineers. They're the nicest people you would ever meet. And they also
That's
now
the
have a
Midwest.
nonprofit. They have a nonprofit company called Near Space Education. Their LLC is Near Space Launch. So they were started by two professors at Taylor University. So if you're in Indiana, you're close to them, and I could think that there could be some great synergy there as well.
Absolutely. Near space in Indiana actually rings a bell. Was there somebody at your conference who
Yes.
runs that?
Well, one of the development guys was there. I'll give you an idea. They're doing 30 or 40 high altitude balloons during the great eclipse in April in Indiana. I think they have 30 balloons they're putting up in April with schools to capture images of the eclipse as it passes over. So, you put GoPros on the high altitude balloons, and when there's the total eclipse, you get this beautiful imagery of the ground, of the shadow of the moon moving across the earth. So it's a really big deal to have this great eclipse passing right through your neck of the woods.
Very cool. Yeah, I might have to reach out to them.
I'll be glad to connect you by email to some of those guys.
Well, as we close, we always like to ask the same question, and that is really any advice that you have for young listeners out there or parents of those young listeners who might be kind of interested in this field, or maybe just in general about, whatever advice you have.
My advice would be, it can be intimidating if you have an interest in space or satellites or whatever it is. And when I started on the Cube satellite, I thought, oh my gosh, I don't know anything. Everybody knows so much more than me. And I was just this noob, which I was, but I learned very quickly that if you spend an hour researching something and actually digging into it, just all you need is an hour. And I guarantee you will most likely be the subject matter expert in the room.
Wow.
And so I think that's my greatest piece of advice, is that you don't have to know anything to get started. Just having an interest and Googling it is going to be the biggest thing, and getting connected with the people who can teach you and get you hooked into things like the two of you right here. That would be it.
Wouldn't you agree the CubeSat community is very collegial and they share a lot? And it's I find that in some industries, everybody's very closed mouth about what they're doing or helping others. But for some reason, the CubeSat is a very inviting environment where you can find anyone to help you almost on any subject if you'll just ask them.
Absolutely. I was listening to one of your previous podcasts, and you had asked the person if they would share the code, or their not just the code, but all of the notebooks that they've learned from lessons learned, people graduating who had worked on the project. And she said, absolutely, yes, all of that information is going to be publicly available anyway once it launches. And so I think that we all recognize that space is tough. There is a lot going on, and
Right.
the more we can utilize each other to help each other out, the better benefit that we are. So I would absolutely agree with that statement.
Well, thank you for being such a good ambassador. And I think we'll end up working together in different ways to help many kids in the future. So thank you for being with us.
Thank you,
Thanks for
Holly.
having me.